Alright, looks like we're live. Hello everyone and welcome to yet another Azwazin session. How about that? Bet you didn't expect that shit to happen yet again. So, let's make a little bit of an announcement on our Discord server and officially start the stream. So, what we're gonna do, a red circle live on Twitch, and today we are printing colored text in Rust. Right, I'm gonna give the link to the Twitch channel where we're streaming, twitch.tv/starting, and I'm gonna ping everyone who's interested in being pinged, and there we go, we officially started the stream. So the stream has been officially started. So today we're gonna continue developing Nock, which is very simple programming language for you know, transforming algebraic expressions and stuff like that. And today I finally decided that I'm gonna start working on a better REPL for that language, because the language itself is more or less done. The core of the language is more or less done, and I think it's time to think about, like, you know, nice features like a better REPL with colors and stuff, auto completion and everything, you know. Hello Agduk, hello Gumar Kamole, Lil Ouija, I hope I pronounced your nicknames correctly. Hello, welcome. Cheers, by the way. So let's take a look at the current state of the language. Mustafa Kura-ish, I hope I pronounced your name correctly. Adixik, Farcon00, Nuffly, Xlix1, MM2PL, AGE, Roberta61. Hello, really glad to see you all. So how are you guys doing? Let me go to Nock and see if I have any changes in here. So I'm gonna fetch the latest stuff. So I've done some work off screen, right? So I need to fetch it and merge it. So it's going to merge origin master. There we go. So there's quite a few things. I recently changed the way you do the rule application. So for those who doesn't know, this is a language for transforming algebraic expressions and stuff like that. For instance, you can start the thing by cargo run, but it's better to wrap it in RL wrap because we don't have a proper, you know, REPL. So we're gonna have some sort of like a, how to say that, you know, REPL substitution. I don't know. Hello everyone, how are you guys doing? Hello. So it's gonna take some time because we need to compile everything because it's Rust. And let's consider some algebraic expression, right? Something like b minus b plus a, right? So we know that this should be equal to a, right? So, but we want to demonstrate that, right? So we want to demonstrate that somehow. So we can define some sort of a rule saying that anything subtracted with itself is equal to 0. Right, so before you would apply such rule, right? So maybe I'm gonna actually, you know, assign some sort of like an identifier for that rule. So how should we call such rule? Something like self-destruction. I don't know, but is there any name for such sort of like a axiom? Because I don't know, additive zero. I'm not sure if it's additive annihilation. What's up? Annihilation, equilibrium. It feels like it's very interesting. So if you consider some sort of algebra, right? So we're talking about abstract algebra. So in abstract algebra, you have certain, you know, operations, and you have an identity element. Is there a name for such a phenomenon when you apply an operation to the same element and you get an identity? You know what I mean? Right. Is there a name for such thing? Inverse law. Is that an inverse law? Yeah, 0 is a neutral number. I know that, and that's my question. What's the name for a phenomenon, for a thing, when I apply an operation to the same element and I get the neutral element? What's the name for that? I know that the name of this element is neutral, but how do you call such law that gets you the, you know, it's an inverse law, right? Oh, I see. Because All right, so if we look at the algebra that only contains plus separation, doesn't contain minus separation, but also has negative numbers, right? So also has negative numbers. In that case, yeah, okay, so this is more of a like inverse, right? So let's actually call it inverse, right? And now, right, before you would first have to define to how many sub-expressions you want to apply this rule, right? So you would do something like all sub-expressions apply a rule inverse, right? I recently changed that, so now you first define the name of the rule that you want to apply and then to how many sub-expressions you want to apply, right? And if you do something like that, you get 0. So I think it's a little bit more convenient because what I found is that I first think about the rule that I want to apply to the sub-expression and then to how many sub-expressions I want to apply it. So at least for myself, this kind of order is a little bit easier. And because of that, like anonymous rules are slightly different. They don't require like double colon anymore. If you want to say something like 0 plus a equal a and then say apply that to all sub-expressions, it will also work. Which makes it even more convenient. So now you can only use anonymous rules, like always say that a plus b equal, you know, something like 69 and then apply it. It just makes it a little bit more convenient. And then you can say that, yeah, there we go, I finished transforming the expression. So this language basically is about that, right? So it's basically about that. So now what I want you to do, I want it to do the following thing. So you can load files, right? So you can do std, std-noc, and in the standard library you have a bunch of rules defined for different things. And what I want to be able to do, I want to be able to start like transforming an expression, right? And then, for example, as I type, I want the system to automatically deduct what rules are applicable and auto-suggest those rules for me as I type them. You know what I mean? So maybe it will actually drop down something. Maybe we're gonna reserve like 3 or 4 lines for auto-suggestions. And as you type below there, on those lines, you're gonna have auto-suggestions of certain rules, right? Some ID. And here's the interesting thing, since you indicate that you want to apply the rule by putting bar in here, right? Putting a bar may be an indication for a different auto-suggestion. So as soon as you put a bar, interactively auto-suggestion should switch to a different mode, which allows you to pick a sub-expression. Right, it will allow you to pick a sub-expression and then it will substitute it with a number which sub-expression to apply or all of them. Right, in all of these cases, you need some sort of an area below a REPL, below a prompt, where you're gonna have all these auto-suggestions. And all of these auto-suggestions like will have a way to apply things to certain sub-expressions. And what was I thinking about, how can we convey a certain sub-expression, right? So if I want to say, I want to apply this rule to that sub-expression, I want to print the whole expression and then highlight the sub-expression with a certain color, right? So I need to learn how to do that, right? I need to learn how to take expression, then extract a certain sub-expression from that expression, and then print the whole expression, highlighting a certain sub-expression. If I learn how to do that, then I can use that in auto-completion to visually show the user what sort of sub-expressions they can choose. You know what I mean? You can probably get it to tell you what sub-expression the current number matches. Yeah, exactly. You can do a lot of things, right? But first we need to learn how to print colors in a terminal. And then we need to learn how to like grab all of the matching sub-expressions within an expression. And then having a sub-expression, how can we highlight it? So this is what we need to learn on today's stream. Right, that's the goal at least. And then once we have this sort of like basic core part, we can build a REPL around that with auto-suggestion, auto-completion and stuff like that. So that's the idea. So I think we've got a couple of subscriptions. Thank you so much, Sajad Haydari, I hope I pronounced your name correctly. Thank you so much for Twitch Prime. And Pituvna, thank you so much for tier 1 subscription. Thank you, really appreciate it. Okay, so first let's actually learn how to print colors in terminal for Rust. As far as I know, Rust has a very lightweight library called Termion, right? So, which is relatively cross-platform, but I think it only works for on POSIX systems. But at least this is something, right? So this library should be easily replaceable. I just need something that can print colors on the terminal, so I can test the sub-expression highlighter, right? So the primary goal is to learn how can we highlight a certain sub-expression, so I can just like show that to the user, because it's kind of like not a particularly obvious thing. Maybe we're going to have some sort of a function that accepts a reference to expression and a reference to a pattern and returns a vector of references of sub-expressions, but those has to be references to actual sub-expression, so we can then compare them as we recursively traverse and render everything. So, and since we're starting to get references to like pretty complex objects and stuff like that, it might become pain in the ass when the borrow checker kicks in. You know what I mean? So let me see. So probably I need to, let's go to the crates. I usually don't use third-party dependencies, so I don't know how to use them. So turn me on, and as far as I know, it's pretty lightweight. I hope it's lightweight, so it shouldn't pull too many third-party dependencies. Okay, so we're gonna just like use the latest version. I don't know. So toml, and I'm gonna just put this thing in here, and I'm gonna try to just build everything and see for how long it's gonna go. We'll see. Okay, so here is the color, and it should be relatively straightforward, right? So you just like import color, and it has a bunch of codes that you can like use or whatnot. I'll see how it goes. So there's also some stuff to control the cursor, which could be very useful, I think. So we can do go to and everything. So, and the way I want to have auto-completion, by the way, in Node, as you can see, the prompt is the last line, right? But once you start typing evaluatable expression, it just adds additional line. The prompt stays here, but you have additional line in here showing you what the expression is going to be, right? What is it going to be? There we go. So, and then once you print it, it sort of materializes. I want to have something like that with auto-completion, right? So, and with auto-completion, instead of a single additional line, you're going to have like 3 or 4, where you're going to have suggestions, and by pressing up and down, you'll be able to choose those suggestions. But by pressing left and right, you're going to be going left and right in the terminal and stuff like that. So this is how I envision this kind of thing. I think something like Termion should be enough to do that. So, and okay, so I suppose it is updating crates.io. It is still updating crates.io. Okay, does anyone have any questions? Node has such a good REPL for such a horrible language. I mean, the language was designed to be horrible. Third-party dependencies. Yeah, I have to wait half of an hour for a third-party dependencies with just ANSI codes in it. Node.js is a great implementation of a bad idea. It's not even implementation, it's just a wrapper over V8, isn't it? So the implementation is V8. But Node is just a wrapper. A wrapper. It's like Dino, right? Dino is also wrapper, another wrapper around V8, but it uses Rust because it's cool. And it also has a built-in TypeScript compiler, which is like, I don't know how they put that together, because TypeScript is written in in JavaScript, like I mean in TypeScript itself, so it compiles down to JavaScript. So you have V8, which is written in C++, which evaluates probably, if I understand correctly, the TypeScript compiler, and all of that is wrapped in Rust, right? So it's just like I just trying to imagine how Dino looks like inside, like architecturally, and it just looks like three things duct taped together, right? That's what it looks like. If I understand correctly, I never looked inside of Dino, but if I understood correctly, it must be just three different things literally duct taped together so they don't fall apart. How much harder is it to write VT code yourself? It's actually pretty easy if you know where to find them. I have no idea where to find them. So if I do something like ANSI/VT codes, can I literally find a convenient list that I can just like search like documentation of Termion? So I found VT FFCR escape, which is literally not what I want. I want a full list that 100% works like every time, so I don't have to stitch together different pieces of information from the internet. Of course, at some point I'm gonna do that, but right now, as I stream, I really don't want to do that. Right, so where are the colors? Is that a full list? Will it work everywhere? So there are some color codes. Probably can just try to do that. Xterm escape codes doc really good. I can link you it. Okay, Xterm escape codes, right? Xterm escape codes. Control escape codes. So the main problem of not doing that is just like simply documentation, right? So I don't want to deal with, you know, scattered documentation all around the web, contradicting each other all the time and stuff like that. So I also want to be able to quickly search for things, and that's the only thing I care right now. So, and okay, so where are the colors? Like, I didn't see the colors, right? So that's the problem. So the problem why I'm trying to use that dependency is literally this. Right, I'm just like looking for something and I don't fucking know. I don't fucking know. That's why I have to wait. That's why I have to wait. It is what it is, chat, and it isn't what it isn't. Right. Okay, so, and as you can see, it works. Okay, so I suppose it took some time to basically update the crates, right? So the main problem was update the crates, but once you downloaded everything's fine. And as you can see, like what I said, it doesn't really have that many dependencies, so it should be fine, right? Check Wikipedia, there are good tables for it. I'm telling the chat, I don't want to go all around the internet stitching pieces of information together. And what the chat responds, they post different places of information where I can stitch it together. Like, I'm telling you, this is literally what I don't want to do. I don't even know how to respond to that. Like I said, I don't want to go all around the internet, at least right now. Right, so maybe later off screen when I have time and when I have in the right mood I can do that, but that's, I don't know, chat, I don't know. So all right, let's go and try to maybe print something with a specific color. Okay, so of course at some point I'll just see how I can get rid of this dependency, but right now I just don't want to think about that. Right. So where are the colors? So this is go to colors and use Termion color, right? Use Termion color, right? Print ln and we're just gonna print red, right? So this is red color. FG, at least that's what it says. Can I have dark theme in here. Is there any easy way to do that? There's probably easy way to do that, but I'm too lazy to actually, you know, look into that. Okay, so this is how we do red, and I suppose this is going to leave the red color after the execution, right? So it has to be cargo run, right? So there we go. So this is the red color, and yeah, that makes sense. After that, we can just reset everything. Okay, cool. So we have colors. Is there any way to reset everything? So there should be, yeah, here is the reset, and I can just like print color reset. So okay, and if I try to print the entire thing in here, okay, excuse me, so it has to be of G, right? It has to be of G. Okay, so here's the red, and there is like reset and everything. Cool. So now we need to somehow get a certain sub-expression, right? So we need to get a certain sub-expression, especially if we have, you know, expressions and stuff like that. So let's actually start with parsing the corresponding expression. So we're gonna have a source, and in here I want to have something like very simple: A plus B, A, B plus B, B, right? So we have like 4 multiplications, and we can probably, you know, color them as sub-expressions, right? So this is going to be the source code, and I want to turn it into AST. To turn it into AST, I need to lex it first, right? So I need to create a new lexa. Right, so I don't quite remember. I think I have to turn it into characters, right? And then I have to put none because it's the file name of the source code that we're lexing, right? So this is what I'm trying to do. After that, I need to do expression parse, right? And I have to pass lexa as a mutable reference, and that should give me the AST, right? I'm gonna unwrap this entire thing, right, because it may throw an error, and I'm gonna print the AST, right, just to see how it looks like. There we go. So I'm gonna just try to print it. And it didn't work for some reason. I'm not sure why, because I actually just built it, not run it. Okay, so here is AST. So we successfully parsed that expression. As you can see, we have multiplication, addition, variables, and stuff like that. If we parse it as, if we just render it, right, it will be rendered exactly as I typed it, right? So this is the rendered version. It also includes the parentheses just to, you know, emphasize the order of the operations, because we have same operations on the same level, right? So what I want to do, I want to find all of these like 4 sub-expressions, if you know what I mean, right? So I want to have some sort of a pattern. I want to have some sort of a pattern, and the pattern is going to be so one multiplied by another, right? So I need to encode that pattern somehow. So I need something like pattern source, right? So this is a pattern source, and then we're gonna have a pattern AST, where I just like take this entire thing, right? And I just do pattern source, right? So here is the pattern source, and let me print the pattern source. So here's the pattern source, and this is basically that, right? So let me see. Okay, so here is the pattern source. So now, what I want to do, I want a certain way of, yeah, I need a function, right? I need a function that accepts the expression, right? So some sort of expression. And then it also accepts a pattern, right? And it should return me all of these sub-expressions. All of the sub-expressions that match this pattern. So as you can see, it should return me a reference. I'm not sure if it will work, because we're getting into this situation of like lifetimes and stuff like that. So I'm not sure how well it is going to work. So this is basically where we will have to wrestle with the borrow checker, right? You know what I mean? So how should we call it? Match all sub expressions, right? Match all sub expressions. So as far as I know, in somewhere here, so if I find implementation of the expression, there should be a method pattern match, right? So here is the method. So it accepts an expression and a pattern, right? So it accepts a pattern. Actually, this one is rather interesting. So who is the pattern? So pattern match. So pattern match, when I ask for pattern match, how does it even work? Right, so we have a head, so first one is a pattern. So maybe because of that, I'm gonna put a pattern somewhere here, right? I'm gonna put a pattern somewhere here. Okay, and because of that, I think I wanna do something like match all sub-expression. I'm gonna put the pattern AST in here, right? So it's gonna be this, and then a regular AST in here. I'm gonna try to iterate through this entire thing. And this is going to be sub-expr, right? So this is sub-expr, and I'm going to literally print all of the sub-expressions in here, like so, right? Sub-expr. Let me see if this entire thing is going to even compile. All right, so this is not expected lifetime. Okay, so this is what I was talking about. You need an explicit lifetime, I suppose. Maybe it could be deducted, but I don't really know for sure. Maybe it could not be. Okay, so it compiles at least, which is pretty great, right? I really like that. But I'm not sure if this thing will require like lifetimes. We'll see, we'll see. So now, what I'm going to do. So all of these references are immutable. That means that we can have several of them, right? And that won't cause any problems. The only thing that we're not allowed to have is to several, you know, constant references and a single mutable, right? As soon as you have single mutable, you can't have a single immutable. I think that's the rule in here. I don't remember. We'll see. Okay, so let's do pattern, right? And we're gonna have a pattern match, right? So this is a pattern match, and we're trying to match that specific value. This is how it works, right? So this is the pattern, and we are trying to pattern match it. And if this thing is sum, that means that this specific expression matches that specific pattern, right? It does in fact match this specific pattern. So interestingly, I think we need to organize some sort of an inner match all expression function, inner one, because we first will have to create a result, right, vector new, and then we'll have to return it in here. And the inner function is going to like recursively traverse the expressions, right, and then collect everything into like this thing, this specific thing, and then like move it out of the match all sub expressions. So let me quickly do it like that. So this one, though, not really sure. Maybe that's gonna be fine, but anyway, sub expers, right? So this is gonna be a mutable to a vector, and I wonder if I can. So this one is gonna be expression, and this thing is not going to return anything, right? So it is not going to return anything. So this is that, and this is that. Okay, let's see if this entire thing is still compiles. Maybe it does not. Surprisingly, it still compiles. How about that? When it has more than it has to choose, that's why you required. Thank you, that was never my problem. Anyway, so okay, let me see. If we match this entire thing, right, what I want to do is just like do sub-expression push, right, and I'm gonna just literally add this expression in here, right? So let's see, does it still compile? Okay, so it requires So now we put the sub-expression, but we'll have to go deeper, right? We'll have to go deeper. So, and we'll have to go deeper regardless of whether we matched the sub-expression or not, right? So because of that, I'll have to do something like match expression and just go through all of the possible sub-expressions. But what are the possible sub-expressions we have? Right, we have symbols, variables, applications, and operators, right? So these are the things that we have. In case of a symbol, I think we don't really care, right? So there's no need to go deeper, right? I didn't think there is a way to go deeper, so I'm gonna just say if it's one of those, just simply ignore, right? Simply ignore. Then we have the head and the body, right? So this is the head and the body. And in that case, we have to do a recursive thing. So this one, oh, by the way, this one is interesting. So I didn't have to say implementation here. And also I never called this function. That's probably why it's so easily compiled. So it's probably gonna bite me in the ass. All right, so this is gonna be a pattern. Right, then we have a head and then we have a body. Both of them are boxes, which may require me to like dereference them because the expression is already a reference. So we'll see how it goes. So this one's going to be head and this one is going to be body, right? So there we go. So the operation, so this one is the left-hand side, right? So the left-hand side, and this one is the right-hand side. And this one is kind of similar if you think about that, right? So this one is left-hand side and right-hand side. And yes, let me see. So okay, so what does it want? I see what it wants because it needs to have like expression in here. The specific operator doesn't really matter, right? So I'm going to ignore that. And this one is going to be expression, and this one is going to be expression, right? There we go. Seems to be compiling, except in here. So what do we have in here? Supply to argument function takes 3. Are you sure about that? Yes, I am sure about that. So I forgot to provide sub-expressions in here. Right, so I need to provide them in here, and have to provide this in here, and have to provide this in here. All right, so what else do we have in here? Okay, what do you want? Oh, this one is rather interesting because body is actually arguments, right? So we can say that it's more of a like arguments, and we can iterate through the arguments like so. Alright, and for each argument we can just try to match the sub-expression and it just simply collects everything. Okay, so everything seems to be compiling. Really like that. Really like that. But the problem here is that I never call this thing, so it doesn't really mean anything. So here I have to do this one, then this one, and then I'll have to provide the mutable thing in here. And only after that I may try to return it. So I kind of want to call it sub-expressions because I kind of like it sub-expressions, right? Sub-expressions, and there we go. If I try to compile this entire thing, it does not compile. Let me see, because I just copy-pasted the code. I like to copy-paste the code, and all right, it seems to be working. So I managed to actually do that, right? So I managed to write a thing that collects a bunch of references into a tree. So we literally have a tree and we collect a bunch of references within this tree, but since all of these references are immutable, so that does not cause any problem with the borrow checker, right? If I understand correctly, there's a bunch of warnings in here, but those warnings are not related to the actual problem. They're just related to the fact that I renamed entry point to something else, and I have a bunch of unused things right now, so this is totally fine. So now here's the original source code. Here's the pattern that I want to try to parse, and let's actually try to match all of these sub-expressions and just print them at least. Right, so I just want to try to print them. There we go. So I managed to print them. The original expression was this. I found all of the sub-expressions that match this specific pattern, and I collected them and I printed them. Okay, this is very fucking cool, right? This is extremely fucking cool. And the reason is because now I can simply write a function that prints an expression, right? But also accepts a reference to the sub-expression to print that specific sub-expression with a different color. Let me show you. So essentially we can write a thing that print expression highlighted, right? And in here we're gonna accept original sub-expression. Of course we're gonna have like references and whatnot. Original sub-expression, and then the sub-expression, or rather highlighted sub-expression, right? And that thing should print that highlighted sub-expression with a different color. You know what I mean? Right, so yeah, essentially. I wonder if we really need lifetime in here, right? So I'm just not gonna provide any lifetime. And I hope it should be as easy as just comparing expression and highlighted sub-expression. Can you in Rust compare two references and say that, okay, it's the same reference, and then do some logic based on that? I wonder if you can. What if they all are star? Does it infinitely recurse? All are star. What do you mean by that? What do you mean all are star? This doesn't tell me anything. What is all? What do you mean? Do you mean something like this? Okay. So first of all, you need to understand how this specific thing is going to be parsed, right? So this is what we need to understand first. So let's actually try to print this entire thing. I'm gonna just render it back. So essentially what I'm doing in here, I have a source code and I parse it into AST and then I print it back, right? Like so. There we go. And you will see that it got parsed like this, which makes it super obvious to how all of these sub-expressions are going to be captured. So you have this sub-expression, then this sub-expression, then this sub-expression, then this sub-expression, then this, and so on and so forth. Right. So, and if I uncomment everything in here, my Emacs is actually slowing down for whatever reason. I don't know why. Yet again, it's probably my computer, not really Emacs. Yeah. So I don't understand how did you came to the conclusion that it has to recurse indefinitely? I don't know. You probably haven't watched my previous streams where we developed this parser, right? So I recommend to watch previous streams. Anyway, so let's do some work. Let's do some actual work. When I need to do the highlighted sub-expression, right? So I suppose what I can do essentially is just print ln, right? So this is a print ln. This is another one. This is another one. So this is going to be color, foreground, and we have to decide what's going to be the color though, right? So let's actually use something like blue or maybe green. As you can see, green looks really nice in here, right? So we're going to say that it's green. Right, so this is going to be green. Then I'm going to try to print the expression, the current expression, and then I'm going to reset the current thing, right? So I'm resetting the current thing. There we go. So I have to put reset in here. Otherwise, if this thing is not highlighted yet, we have to... This one is really interesting. Right, so we have to try to print it. So it feels like I need to copy paste the rendering of this thing, right? So we have implementation of FMT display for the expression, and what I need to do in here is just like copy paste this process, right? I'm not sure how exactly I'm going to reuse this code, right? And if whether it's reusable, well, it's definitely reusable, but I'm not sure how exactly I'm going to do that, right? So, but so this is something like this. Print highlighted. Damn. It's not super easy. It is really not super easy. The easiest way would be probably print the original expression, then maybe find the offset of the expression that you want to highlight, move the cursor there and print it again with a different color, if you know what I mean. Maybe that could be an easier way to do that. But it would be kind of cool if it was recursive, right? We detected that we're printing the highlighted message, so let's actually print it highlighted, right? Yeah, I was also thinking about the Haskell approach, right? So creating a separate type and then use formatting for that. So whatever you suggest in Robothik is a Haskell approach, right? So essentially like wrap it into another thing and create an interface for that. So I also was thinking about that. It doesn't make it easier though, right? So it doesn't mean that I like magically don't have to do any work, right? So I still have to do some work by creating that instance and also adapting that code to that instance, still probably copy pasting that code, right? So still probably copy pasting. So it doesn't really reduce the amount of work. It's one of the possible things, in a space of possible things that I can do. So I do have that in mind, of course. All right, so this thing, okay, so let's go the following way. If this thing is not highlightable, right, what I'm trying to do is to simply print feels like the data structure is just not correct for what I'm trying to achieve. It just like feels like the data structure is not particularly correct. And that's the problem. That's a huge problem because I'm trying to restore some stuff. Alright, so let's imagine that I need a function that calculates offset, right? Offset. Sub-expression offset. We get the original expression, right? So we get the original expression and we get the sub-expression, right? So we get the sub-expression and that thing should give me the offset, and I want to implement that function using only the display interface implementation for the expression. How can I do that? How can I do that specifically? There's no particularly easy way to do that, especially when we have such a complicated logic. So if you take a look at the FMT display for expression, right? It should be relatively easy, right? So if we had an opportunity to say, okay, so we know that there is some sub-expression. If self is equal to sub-expression, right, we're about to print a sub-expression. The offset within the formatter is the offset, right? So that's how easy it is to get the offset. Only if we could inject the sub-expression into the display, right? If only we could do that. And if only we had an access to the offset within the formatter. Right, so the information about that is right there. The information about that is just like right there. I just need to extract it because we have this, you know, type system masturbation and stuff like that, I cannot just like get it, right? So it's there, but you can't access that because fuck you. So which right is like a very interesting question, like what can I do about all of that? So though maybe we could extract like the way we calculate offsets and print everything and then implement display in terms of this entire thing. So we don't necessarily have to use this interface. We can have whatever interface we want and then adapt that interface to the display so it's printable. It's printable there. Like we don't have to do it this way, right? So we can just like do whatever we want. That's kind of the point in here, isn't it? So yeah. This is really annoying. Okay. Let's see any other way. Right. Where was that? Print highlighted, right? Print highlighted something, 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 right? So if it's a name, I just print the name. Okay, cool. So if it's a head and args, we take a look at the head, right? We take a look at the head. And if it's one of those names, we just print the names, right? We just print the names. If it's something else, we have to print the others, right? We have to print the others. Though the way we can print that, is rather interesting. So essentially, I'll have to split this entire thing into two. So by the way, this thing can fail with IO result. Right, so I'm going to just like copy paste this code and adapt it to whatever I'm trying to do, and then see if I can improve it somehow or make it like simpler or whatnot. Right. So this is what we're gonna have in here, then right. But this one is very interesting, so it has to be print expression highlighted. And I'm gonna literally print that expression highlighted sub-expression. Right, and we're gonna put it like this. So, which raises a very interesting question. So what if the print expression highlighted returned a string? Right, what if it returned a string? What if it returned a string? And which brings us back to the idea of having the thing something like highlighted sub-expression, where you have an original expression and the sub-expression, right? And then you have a FMT display. So it kind of actually goes relatively well there. It goes relatively well there. So maybe this is something that I'm going to try to approach, but that will require doing something like this, right? You see? Okay, so if it wants to go that direction, let's actually try to let it go that direction, right? Instead of this thing, we're going to have something like this. Okay, so sure. Implement FMT display. Display for that specific thing, and it's gonna be FMT. We're gonna accept immutable self, right? Immutable self. I wonder if I'll have to do something like this. We'll see. The compiler should tell me. I don't know. So the formatter, right? Formatter, and then we're gonna return IO result, right? So what we have in here is essentially highlighted sub-expert. So we have original expression and then sub-expression, and we just like destructurize everything in here just to get to the thing we're trying to do. So then I'm highlighting this entire thing, right? So I'm printing the expression. If they are the same, I'm just using the FMT display implementation of the original thing. If it's not, I'm going to be copy-pasting that thing from other FMT, right? So my real problem in here is that the logic of printing the sub-expression is relatively complex because we're trying to, you know, be a little bit pretty. Right, we're trying to be a little bit pretty, and that's kind of the problem that arises in here. So here's the other, but we'll have to wrap it. We'll have to wrap that other into this thing. Right, so essentially what we'll have to do, we'll have to go through all of the calls of FMT here and just like redirect them back to the highlight sub-expression. That's essentially what we'll have to do, which is a rather interesting thing. And again, it creates the discrepancy between that implementation of FMT display and another one. And maybe there is a way to abstract it out by creating another interface or something like that. We'll see. Maybe there is a way. Right. So, and we'll have to do that in all of these places. Right. So highlighted sub-expression, sub-expression. There we go. And we also have to do that in here. Highlighted sub-expression. There we go. So this is what we have. Right. Isn't it cool? Isn't it cool? I think it's pretty cool. Okay, let's try to compile this thing. And it does not compile, because why? Because I'm an idiot, right? So let's actually make this sort of structure, right? So I think it's a bit better. Because of that, it will require a slightly different destructurization, right? So this is a formatter. It comes from FMT. This one has to be FMT, I suppose. Right. So what else do we have in here? So expected tuple, right? So we can destructurize it as this thing. Though we didn't really have to, I can like refer to them directly, but it is what it is. Not found in the scope. Okay, so it has to be sub-expression. So these are minor things that are super easy to fix. I don't even pay too much attention to that. So this one is the original expression, right? This one is the original expression, and then that one is a sub-expression. Now I can use a little bit of an Emacs magic, as you can see. So this is his expression, this is sub-expression. So where is another one? So we're gonna go over here, expression, and here sub-expression. What else do we have? Okay, so what's that? Okay. What I'm scared about, by the way, is... Right, I probably should have to do like write a len in here into the formatter. I think I have to do that into the formatter. Right, because eventually I'm gonna write everything in there. This expression has type highlighted. So that means here I have to do expr. All right. Holy shit. The entire time as I was fixing all of these problems, I was constantly scared that it's gonna be something about the lifetime, right? I was constantly scared that it's gonna be something about the lifetime, but I suppose since we're not having any mutable references anywhere, like all of that is completely immutable, right? So there should be no problem with the lifetimes, right? We're not trying to, well, except we have this mutable reference, but it's completely from a different lifetime of a different, completely different object, right? So yeah, it shouldn't be that much of a problem. Okay, so what I want you to do, right? Let's go back to like here, right? Let's go back, and these are the sub-expressions that we're trying to match, right? So these are the sub-expressions. It's gonna take some time. And then I'm gonna try to print them like so. I'm gonna try to print a highlighted sub-expression, but I'm gonna use the original expression. The original expression is AST, and I'm gonna say print that, but with this thing highlighted, right? So, and it's gonna print this expression 4 times. And each time it's going to highlight a different sub-expression in here. So each time it highlights a different sub-expression. This is what I'm trying to achieve. Fuck. Okay. Oh, this is because, yeah, I keep forgetting that it's like this thing. Okay, get ready. It has to be a reference. Yes, yes, yes. One more time. Almost. Okay, so let's actually, I mean, it compiled. That means in terms of lifetime, it's fine, I guess, in terms of like lifetime. But I'm not sure what exactly happened there. Is that because it's right len? It has to be just right, I think. I think it just has to be right. Okay, so I'm not sure if reset here is a good idea, right? So maybe reset may create a problem, but let's hope that it will not. Okay, so that didn't really work well. That didn't really work well. So maybe I'll have to set a completely different color in here. Color default instead, maybe. Maybe I should have to use the default, because reset seems pretty aggressive, right? Or maybe, by the way, I'm using Emacs. Wait. There is no color default. So you're just suggesting things without actually knowing what's there. I thought you like know what you're saying. Okay. Yet again, listening to chat. Okay, so this could be a problem of Emacs. Let's try not to rely on Emacs in that sense. You know what I mean? Okay, it was Emacs. Look at it. Where is Poggers in the chat? Where is Poggers in the chat? I don't see Poggers in the chat. Right. Chat. Where is Poggers? So we are capable of doing this kind of shit, bro. But we achieved that through copy-paste. Right, we achieved that through copy-paste, and the question is, how can we get rid of that copy-paste, right? Because what if I want to change the format of the expression? How do I not duplicate that much code, right? So that's a really interesting question. So maybe I can have an interface of just an expression, right? So just an expression, and I don't even know, right? Because this thing has to go back into itself, and it's just like, yeah, I'll have to think. I'll have to think how we can do that. Right. But in any case, we have something that can highlight stuff. Right, and now this could be used quite easily. Could be used quite easily for auto suggestions, right? So essentially, as you start typing out the rule, right? You said let's apply a plus b equal b plus a. You type something in here, right? So you type something in here, and the REPL should successfully parse this rule, right? It successfully parses this rule, uses the head of the rule to find all of the matches of the currently shaped expression, and then show this list in an auto suggestion, right? So it has to be something like that, I think. It has to be something like that, but we'll need to think how we can approach that. In any case, we already have something that can highlight shit, which is pretty good. So the name is actually kind of huge, right? So the word highlighted, right, is very, very long, and I don't know how to replace it. So it's a good question. It's a good question how we can make it less highlighted. So I also need to maybe rename this entire thing. So it's not really match all sub-expressions, but rather find all sub-expers, right? So we're trying to find all the sub-expers. Find all the sub-expers. So I'm gonna keep this function in here. And then at some point. Cool. All right, so let's go back. So I'm gonna probably create a separate branch. So here is the lock, here is the termion. Okay, better REPL, right? So we're starting to develop a better REPL, and then I'm gonna say add termion to the dependencies, right? So we're starting to depend on that. At some point I'm gonna get rid of it, but yeah, because it's just escape codes. But maybe it's gonna have something that is not avoidable, but yeah, for now it's gonna be fine. Implement some machinery for highlighting sub-expressions, right? So I'm going to push that right into the repo. So we need to develop another machinery for specifically for auto suggestions, right? So it needs to be similar to Node. When I do something like this, it just basically expands, printing like additional thing in here, right? And we want to do similar thing, but instead we want to have like a 3 or 4 suggestions in here. Maybe we're gonna have more, maybe it's gonna be customizable, right? So some sort of like a parameter that says how many lines of auto completion you want to have in here. And let's try to do that. So maybe for now, I'm gonna go with a very interesting thing. So we have a REPL mode, right? We have a REPL mode. Maybe I'm gonna add another REPL mode for like a new REPL, right? So let's actually, so we have a normal, we have a debug parser, debug lexer, and I'm gonna add another one with auto suggestions and stuff like that, where we can experiment with things. So this is actually very cool. For instance, if you want to debug a lexer, I think I already showed that, right? Debug lexer, you can do the following thing, right? Can you rebuild everything? So maybe a plus b, b multiplied by 69, right? So, and as you can see, it just basically split it into tokens, and you can see how certain things are tokenized when, especially if you're updating tokenized. You can also do a parser, right, where you can add certain expressions, right? and it will parse it. It will show you how it's supposed to be displayed, then its AST, and whether it parsed everything. So this is like unparsed tokens. This kind of stuff may happen as well. So you can basically have different modes in here to like test things. It's primarily for the developers. What I'm thinking is that I'm going to add a new mode in here, right? And this is where we're going to experiment with the things, right, with the pop-up and stuff like that. It's not going to be you know, final REPL, right? It's going to be just like a place where we can do things. Start new REPL. There we go. So, and we don't have such thing yet. We're going to put it somewhere here. We're starting a new REPL to do. So this thing is not implemented yet. We probably also need to add a flag for this thing, right? So here we have a debug, and this one is new. Since all of the things that are accessible through the debug flag, they usually have a prefix debug, maybe this thing should be also called debug, right? Should be called debug. So debug. Okay, debug new. Why are you using run? It actually keeps screwing me up, right? Because what I want in here is just like build. There we go. So maybe in here, by the way, I want to do something like allow that code, because for now I don't plan to use it, right? But I want to keep it in here because it's a very useful code, right? Finding all the sub-expressions within that expression is extremely useful. So yeah, because of that I want to just keep it in here. It's taking some time because my laptop is a potato, so I really apologize for that. Okay, so if I try to do new, right, so if I try to do new, it will say this thing is not implemented yet. So let's actually set up the proper REPL, right? So first we'll have to have a buffer where we put commands, and also we need to organize the loop. I'm gonna copy paste the whole REPL in here, right? And I'm gonna just like remove the things that are not needed. Right, so we do need the command buffer, we do need the prompt, right? I don't think we're gonna change the prompt right now, so I'm gonna just keep this as the prompt of the REPL, right? So then we clean the thing, we don't have to change the prompt is gonna be the same. Then we essentially read everything, then we parse the command. We're trying to, yeah, we basically take the command, we try to process the command, and so on and so forth. So for now, I think I'm gonna just remove this thing, right? I'm gonna just simply remove this thing. And I don't even know how we're gonna start. How are we going to start? I just want to try to populate, like maybe I want to wait for a certain command, right? I want to wait for a certain command and then just populate the thing. You know what I mean? Just populate. Okay, so let's do something like this. If command tree is equal to bam, right? Something like bam. We're gonna do something in here. Otherwise, we're not gonna do anything. And here, I'm gonna just do for this in, let's say, pop-up size, right? So this is going to be pop-up size, and I'm going to just say bam this amount of times, right? So we're going to have something like this, pop-up size, use size, and it's just like 5, right? So we want to have like 5 things. So index not quit, so this one has to be just loop. I don't know what's going on with my computer, probably because the music app is very slow again. Okay, so this is new, and maybe I want to change the prompt to actually indicate that so I can distinguish them, right? So because it's indistinguishable from production knock. Right, so I can type some shit in here, nothing happening, and if I do BAM, right, it printed BAM 5 times, right? So that's basically what happened. Okay, so before I can continue, right, so I feel like I wanna try to go back, right? So we have go-to, right, we have go-to, so it means I'm gonna print this thing and I'm gonna go back to the size of the pop-up, right? So let me see. So this is the cursor, right? So this is the cursor, and now I can do go-to, right? So I can clear everything, and then I can go 5 and 3. So maybe this is something that I should try. Where is the terminal? I'm going to move this thing in here, and then the other thing is going to be cursor, right? So this is the cursor. So after the BAM, so we did the BAM 3 times, right? We did the BAM 3 times. I want to go here. So it clears all and it goes somewhere. This is not what we want, that's for sure. Here, I just want to do cursor, go to, and 5, if I understand correctly, is the size. So essentially, I need to, this is the absolute value, right? So this is the absolute value, but I need to have something relative. ANSI escapes a very poor design, and one of many odd aspects is being one base. This can be quite strange at first, but it's not that. Okay, sure. How can we do a relative one? If we want to do a relative one, we need a way to get the position of the cursor, the current position of the cursors. So types that allow detection of the cursor position. So how can we get the cursor position? Types that allow. And who implements that? Anything that is writable, right? So for, okay. That is pretty cool. So that means for the standard input, I should be able to get the current cursor position, right? Cursor position. So this is the cursor position. I should be able to do that. There are movement I didn't see. Where? Move cursor left. Oh, okay, so they're separate. Okay. But I'm still curious whether I can use the cursor position. So where go shaming? What? What's going on here? I don't understand. Anyway, so so this is a go-to. Let me see. So that means we need to probably import that thing, right? So I'll have to go in here, detect. Oh, you're probably talking about the title. Holy shit, I already forgot what I put in the title. Anyway. So method cannot be called on std due to unsatisfied trait bounds. Oh, it's for the write, so that means I have to do that on std out. Yes, okay, that's cool. So I have to do something like std out, and that will give me the current cursor position. It's really interesting how can it get the current cursor position just knowing write. So can write give you the FD? So the only way I can see it being able to give you that information is write knows the FD. Right. Apart from that, I didn't see any other way to do that. I'm actually really curious. How is it even implemented? How does it know that? Cursor position, okay. So F writable, all right. So self flush. That's a lot of, quite a lot of shit. Mm-hmm. What the hell? Okay. So it sends this code. It sends that, where is the cursor? All right. Then it waits a little bit and then it reads that stuff. Holy shit, really? Is that how you get the position of the cursor? You send an escape sequence and you wait for the response from the terminal and you literally parse the response from the terminal, and this is how you get X and Y. Holy shit! I was wondering, how does it know the position just by the write interface? Because write interface doesn't give you that much information, right? Because it seems like a system thing, right? I would imagine that it will need to extract the file descriptor from the write interface, then use something like system specific to get the position and stuff like that. No, there is escape sequence that prompt the terminal to get the position of the cursor or something like that. Like, I didn't even know that. This is so cool. It's so funny and cool at the same time. And because of that, you don't really need anything too system specific, right? So you just send the sequence and you receive like information about that. So the terminal emulator writes the position std. Okay, I see. That's actually quite funny. So that's why it's so useful to read the code, right? You see something weird or interesting in a library, just take a look, just peek into the implementation. I do that quite often and I learn a lot of things. People often ask me, like, where did I learn all of this stuff? And my answer is in front of your eyes. This is how I learned a lot of interesting things, because I use a library, right? And then I get curious, like, how exactly does the library do that? Because I always thinking, how would I implement such library? And then I realize, okay, I don't know how we would implement that. I look into the library, into that specific method, and I learn something. So yeah, there you go. It's always useful to just peek into that. And as you can see, you don't have to read the whole library, right? You found a weird method that you don't really understand how it works, and you can look into that specific method and just like learn something. So yeah. Very cool. Alrighty. So, but we don't really need that, right? Because we have left, right, and whatnot. So we probably need something like up. So move cursor up. Okay, so and it moves it this amount of things. Okay, and we don't really need to do that. And cursor up, and I'm gonna say pop-up size. And that's the reason why I created such constant, so I can reuse this specific constant. So maybe I will have to also switch to the row terminal, right? And control all of the little movements that we can have and stuff like that. So what do we have in here? This one is not used anymore. Okay, guys. So pop-up size, can I just do as, maybe try into unwrap. Thank you, Rust, very cool. Okay, so we have that, and I do BAM, which is rather interesting. So it went 1, 2, 3, 4, and then I suppose it was forced, right? It was forced to be here, right? It was forced to be here. Which raises a lot of interesting questions. So maybe I need to switch to the row mode and like literally do everything myself and handle everything myself. That would be actually rather interesting. So there is a managing row mode. So row mode is a particular state of TTY, signifies that no line buffering, the input is read byte by byte. Okay, so byte by byte. The input is now written out instead of it has to be done manually by the programmer. The output is not canonical. Okay, so essentially there is usual mode that you want to be in, like no buffering, right? Everything is done manually, and so on and so forth. You can just like force std out to be in that specific mode, right? But I'm not sure about std in, right? So I suppose maybe you'll have to have like two of these things. Std out should be in immediate mode, and std in. So there's a row terminal. And what kind of implementations do we have for that? So there is a write. So activate row. Trade implementation, outer trade implementation. Do you have anything for read? Well, because I'm not quite sure. What about the reading stuff? So there is the input. Okay, input is rather interesting. Iterator over input events, term read events and row. Show trait. So terminal read. So we can have events, and what is events? It's a struct. It is a struct. I see. You're printing the prompt, that messes up the drawing. Thank you, Captain. Very cool. So, okay. Let's try to see if I'm in a row mode. What can I do in a row mode? So let's actually go back in here. Right. Because it's unclear what exactly I can do, right? So there's also screen. Wait a second. Managing switching between main and alternative screen buffers. Okay, so that's very cool, but I'm not sure if it's going to be useful for us, right? So I'm going to actually keep it as it is. So there is also scroll to control the scroll, and yeah, let's actually try to play with the row. Okay, use terminal row into row mode. There we go. Into row mode. Std out into row mode. And that will give me a mutable std out. And in here, I want to write into that std out. Okay, so writing that, and I'm going to say something like hello. Maybe world. Colors, FG, color green. I want to go with green, right? So this is going to be green essentially. Colors, FG, color reset, right? Fuck. Okay. Why don't you? Okay, so that should be fine, hopefully. And let's try to run this entire thing. Okay. I cannot jump to the errors. This one is a color. I wish I had a better laptop, but unfortunately I won't have a better laptop in 5 years probably. So probably won't have a better laptop in 5 years, that's for fucking sure. So this is basically the last laptop that I'm gonna have for a while. Alright, so that's pretty cool. So that is still in a row mode, at least it feels like it. At least it feels like it. So, oh no, it actually seems to be fine. Okay. Alrighty. That's very, very pogue. So interestingly, if I start reading stuff from the terminal, right? So this is actually pretty straightforward, right? So it makes sense, right? it does make sense. Cool. std out, std in, I mean. Right, so I want to read a line from here. Right, if I want to read a line. I maybe even read a key, if you know what I mean. Right. So yeah, let's try to do that. So what's gonna happen? I cannot see, so there is no command. Okay, let mutable command string new. Okay. So this is actually very cool, I think, maybe. Though it does not react to anything, right? So I can't even do anything. So maybe because of that, I'll have to start handling everything like manually, completely. So let me find the knock, and I'm gonna kill 73, 72. Maybe I can do kill all knock. Yeah, I can do that. That's for sure. So the next question is like, how can we handle the input, right? So we need a way to handle the input. We have a raw terminal, which is nice. I can do things, but I can't really read from it. Right? I can't really read. The only thing I can see is like input, right? But there's no really examples on how to do that. An iterator over input keys, which is rather interesting, right? So, but it's unclear where can I get that. Right? Extension to read trait. So this is probably what we need, like a read, and you can have keys. Okay. And it's probably a lazy iterator, right? So it's some sort of a lazy. Also, you can read line. Okay, I think that's the thing we need. I think that's the thing we need. This is actually pretty cool. So we need to use that. All right, start new REPL. And I probably also need something like std in. Right, so this is going to be std in. And in here, I did hello world, right? So I'm going to try to iterate over the keys, right? In std in keys. There we go. And what can I do in here? I can probably start, you know, printing things. You know, every time I encounter a key, I can say cursor left, move one left. Why not? Right. So right now we're not going to care about the specific keys. Right, we don't care about the specific keys. But then later we can dispatch upon the keys and do different things upon the keys. Right. And it actually creates a new line for whatever reason. I don't really know why. I know why, because this. Right. Okay. So I can't quit even, which is really interesting. So I probably also need to dispatch. Something. If I press Q, it should probably quit. Right. So this is what I want. I think that's what I want. Subdev Alexei. Of course I support Ukraine. I know way too many people from Ukraine to not support it. Of course. And my babushka was Ukrainian. So. Alright, so let me see. It doesn't really... So is it running or is it not running? I don't know. Okay. So it doesn't really seem to work at all. People were actually saying something about flash. So it was not flashing because the application was terminated. It was flashing because I put ln in here. So that's why it was flashing. So yeah, I still need to manually flash if I don't want to put a new line in there. So you were kind of right. Alright, kind of, not really. But you were. So let me see. There we go. And it does not. Okay, and I still need to flush it in here as well. Okay. kill all knock. All right. Finally, whatever key I press, it always moves left. Okay, I have a full control, I think. I think I have a full control over what I'm trying to do in here, which is super cool. So if I take a look at the keys, what is the item for the key? What is the item for the key? So let's see. The item. So it's the inner. I think it's just basically a map. Oh, okay, it's an event key. You extract the key, and the key is what? Let me see, events. An iterator. My problem is that where are the definitions of those things? Where is the event? Can I see the event first? Here it is. It's a key, and key. This is what I wanted finally. Okay. All right, so you have a character or you have something else. Okay, this is actually perfect. I have a lot of control over everything. Yes. Okay, so this is very cool. So what I can do in here is that I can take the key, right? And if the key, I can even do if let sum, not really even sum, but key character q, then essentially break out of that loop. Otherwise, just move left. I really like the level of control I have now. That's a lot of control. I really like that. I can build a pretty sophisticated REPL out of that. So it's just like building blocks that I can use. So it's a terminal event, and this is a key. Okay. Event. Is it event or events? I think it's events. Unused import. Am I an idiot, chat? I feel I'm an idiot. I feel like I'm an idiot. Undeclared create event. I think I'm getting tired. Yes. Yeah, we have to. Yeah, we have to be super careful in here. I'm already tired. Yes, I can clearly see that. So I'm making like a very dumb mistakes, but I really like that. It's actually very interesting. Okay, so let me kill all knock. Kill all knock, and one more time. And now I'm gonna try to press Q, and it exits. Perfect. I have shit ton of control. I can organize my own event loop. And do different interesting stuff with it. Hey, Lee, brother. Okay, cool. Why not using the TUI library? I'm already using it, it's determined. Why not just use the Electron and make this a web application? Why just implement it? Just why don't you use Vue.js? Is there a way in Rust to see if there is something in the std_in buffer, like piping from another program? That's a very interesting and very specific question. I'm not even sure how to answer that. Okay. I was thinking. You know, I want to try to actually like input things, right? Input things. And as soon as I input something into the buffer that looks like a parsable command, at least it has a shape of head, which is an expression, equal to body, which is another expression. As soon as I have that, right, I should print a list of all of the possible, you know, all of the sub-expressions of head inside of the body. Right, I want to try to develop such interactive program. And if I would be able to do that, I think I'll be able to create a really powerful REPL, right? So, but unfortunately, since I'm going so down into like control and everything, it might become kind of difficult, but it's an interactive thing. So, creates a lot of interesting questions. So we have left and right, up and down, so we have all of these things. So I feel like if I really want to achieve precisely what I want, right? If I really want to achieve precisely what I want, I need to write my own line editor, as somebody said in the chat. I think I'll have to go that route because I want to achieve a very specific UX, right? And if you want to achieve a very specific UX, you need a lot of control. And if you need a lot of control, you have to go lower and lower in abstractions, right? To get to the nitty-gritty of the things. So otherwise, you won't be able to have that level of control. You see what I mean? And that's basically the answer to the question why I'm not using a TUI library, because I want to have a lot of control, because I want to achieve a very specific result. If I didn't really care about specific result, I probably wouldn't do that. So, what is F, by the way? It's like some sort of like functional things. Though implementing your own line editor shouldn't be that hard, in my opinion, right? Because you have all of these things, like you have left and right. You just handle left, right, and characters, and that's it. So they actually, like, a lot of the work is done for you by this library. It's actually pretty cool library, I really like that. Okay, so let's actually try to do the following thing. So we're gonna have a prompt, right? So this is the prompt, new, right? And we're also gonna have a space in here, and maybe I'm gonna put a prompt in here. So prompt. Okay, so we have that. Now, as I handle everything, I need a state of the line editor, right? So we need a buffer, which is just a string, right? So this is a string. Then I want to have a cursor, right? So I want to have a cursor so I can input things there. But not really. Yeah, let's actually keep it as a cursor, why not? So it's going to be a size, and it's going to be 0. Okay. Those are encoded with some... Oh yeah, F1, F2, and F3. Yeah. Cool. So I suppose for the key, I'm gonna just simply unwrap the key, and I'm gonna match it. And if I do have a key, right, a specific key, I'm going to simply insert that key into the current cursor, right? Maybe it would be kind of cool to have a line editor, right? And this is where we're gonna have the buffer, right? The buffer and the cursor, right in here, we're gonna have something like default, and this is where we're going to have methods like insert a character, right? Insert char, mutable self, and this is char, so this one is not implemented. And yeah, that's actually pretty cool, right? And this is where we can do something like left, mutable self, to do left and right. So we'll only have to implement these things. All right, and then at any point we can get a string out of the line editor. And yeah, so what we have to do in here, so if it's a key, so let's actually make it like this. Line editor, it has to be default, I suppose. We're going to create a default one. So if this is a character, line editor insert the character, then key left, left, right. If it's something else, we're gonna simply ignore that. Cool. So here we don't really have to do anything. Interestingly, so this is just a state of this thing. This is just a state. Maybe we also are going to have a way to render that state. Right, so we updated the state, and then we're gonna do something like editor render, right? So which will also do that. So yeah, we're going really low level with all of that stuff, but at the same time, that's a lot of control. That means we can do a lot of interesting things, like really a lot of interesting things, and this is what I like about that. Right. And since Termion is so close to the ANSI terminal, it should be relatively easy to get rid of it if we need to. You know what I mean? Oh, and also, by the way, maybe we're gonna abstract out things like line editor and stuff like that, and make it easy to port to Windows, for example, right? So to the terminal of the Windows. I don't know how the terminal of the Windows works, but as soon as we have like a pretty good interface, it should be relatively easy to do that, right? So we can nail down the specific small features that we need, and we can find the analogs for those features in Windows. Hopefully we can do that. So, all right. So left and right should be relatively easy, right? So if cursor is greater than 0, if it is greater than 0, we can just do self cursor -1. That's it. So nothing else is needed here. If self cursor, so we should allow it to be equal. We should allow it to be equal to self buffer len. And if it's equal to self buffer len, that means it is after the end of the buffer, and you can append. By inserting, you essentially appending things, right? So if the cursor is less than the length, we basically increment this thing. There we go. Basically increment. And in here, this should be relatively straightforward. If self cursor is greater or equal to self buffer length, right? Instead of just inserting that thing, we are appending it. So we're literally pushing. Otherwise, we have to insert it, we have to move things around, and I don't remember how to do that, to be fair. Prompt is also probably, we'll get to that, don't worry. I can see that whatever I'm doing actually gives you a lot of food for thought. It also gives me a lot of food for thought as well. It's just like I'm not saying these things, right? So I know that's why I keep doing that, because it actually gives you a lot of interesting things to think about. Yeah, I know that. So we'll get to that. Rust up doc. That's why I'm so excited because it's going somewhere. It is actually going somewhere. So what I was doing, I don't remember. So I need to find a string. Yep. So maybe this entity has to be called prompt, probably. And now, ooh, do we have insert? Do we have insert? Please, please, we do have insert. Holy shit. Insert the character into string at a byte position. This is O of n, I'm fine with that. At least for now, we're not gonna print like, you know, millions of the characters. You're not gonna type in millions of the characters, so O of n is fine. Even if you type 1,000 of the characters, O of n with n equals 1,000, it's still fine, right? So you don't have to like worry about that. So if you do that at 0, you essentially append. But the question is, at a byte position, can I just like then do self buffer insert, self buffer insert self cursor x? That's a good question. And also they start with a certain capacity, right? And I'm not sure if what does capacity do. Is that an internal capacity? With a particular capacity, you have an internal buffer, right? So I didn't think this thing is necessary, right? So I think it's just like pre-allocates 3 bytes, but I don't think it's needed. So since you can just use the like insert, you can insert things after that, I don't think this condition is necessary. I think it's as simple as that. So UTF don't work. That's a good question, actually. Well, I mean, character is a UTF, and string stores UTF stuff. Oh, yeah, I see what you mean. Okay, so that's a good point. Yeah. All right. And I'm pretty sure vector. Come on. You can do that. So vector should have insert, yes. Insert element at position index. Okay, so that's quite important. Thank you so much. So we can move around and whatnot, and that should be fine. When I want to render this thing, like when I'm rendering, what am I doing is, though I also need to know the position of this stuff, right? Okay, so this is that one. So these are the keys. Maybe I want to keep the keys, but I also want to open the documentation for the cursor up. So I can go up and down, restore the cursor. Restore the cursor. What is a restore? So that means I can save the cursor and then restore it. I can hide steady bar, I can move that, steady underline, that's fine. Blinking bar, blinking block, so different styles and whatnot. So I need to know where the line buffer is located right now. Like I need to know that for sure. And also I need to know where to move that. Where can I move the cursor? Move cursor down. Because that's the problem, right? So to render everything, right? To render everything, I need to go back to the beginning, right? I need to go back to the beginning. Then print whatever I have. I need to print the prompt, then print the buffer, and then move the cursor correspondingly, right? That's what I need to do, which is rather interesting. I suppose one of the things I can do, so if I want to render, right, of course I need to do, take a mutable, mutable, I think, mutable t, right, and that t, I don't remember, so is that something like this? Right, that t has to be, I suppose, extended right, the right that allows me, maybe not, maybe it just has to be right, so let's actually make it implementation, right, so this is what I should be able to do, so that way I don't need the generic, so, so I can do the following thing, and by the way, this is going to return IO results. So let's call it sync. Sync. I probably want to do /r. So I'm pretty sure /r is going to move the cursor to the beginning, but maybe there is something that allows me to do that without this thing. I'm going to try /r. So after that, I want to print a prompt. For now, we're going to accept the prompt here, right? So this is going to be a prompt. Might as well actually put it in here. So this is going to be prompt. So this is the prompt. Then we're going to have the buffer. So I need to construct a string out of the vector, rust vec to string. I don't remember how to do that. Maybe there was a method to do that. How to convert vec of chars to string. I don't remember. And I'm also getting tired, so forgive me. Forgive me for doing that. So you just iterate and you collect it. Okay, so that's fine. Right. So buffer self buffer iterate and you collect that thing into them. Right. So it's gonna be string. I thought maybe there is a better way to do that, but that's fine. That will work. So we have that, and after that we have to go to, the question is, where should we go? We can do one more time something like this. Cursor right, prompt length, right, so this is a prompt length plus self cursor. That's what we're gonna do. Sounds good. Sounds good. Sounds too good. I wonder how can you clean a specific line, but we'll see. That's fine for now. All right, so let's see how it's gonna work. So we don't have a prompt. Okay, so this is a prompt. To expect it, so this is a size. Both of those things are size. So because of that, I will have to try into unwrap. All right. Okay. And this one IO, so it means here I have to do OK. Okay. Line editor type annotation needed. Cannot infer type, and this one is going to be line editor. Line editor. Okay. Insert key. I think it has to be called insert char. Should be probably not called key, but I already did that. So here we have the std out and prompt, I think. Right, so the other way around. Hopefully, finally. Mutable, sure. It compiles, I think. I think it compiles, chat. Holy shit. Are you ready? Are you ready? Oh, fuck. I think I did a fucky wacky. I mean, it types things around. But it does not update the... it does not update the cursor properly. Which is rather interesting. Right. This is because I have to do it here. There we go. Almost. So, yeah. It's a little bit weird. Okay, that's very cool. So we still need to have a little bit of a logic, right? A little bit of the logic with the cursor, right? Because the cursor, as you insert a new thing, I think cursor has to be incremented, right? So we inserted thing and self cursor +1. Okay. So I have no way to handle all of this, so I have to kill all knock. Okay, so let me see. So yeah, you cannot backspace though, right? But I mean, so it's pretty cool. We'll probably also have to handle the enter and whatnot, right? So that's one of the things we'll have to do. But the question is how, right? Is it something like this, right? So where I have key, and here I'm gonna say to do. Is that just a new line? New line. Okay. Come on, you can do that. I believe in you. Come on, come on. All right, it failed. Perfect. So, and with the new line, we can essentially try to handle something, right? For instance, there should be a way for the line editor to take the value out, if you know what I mean. So is there anything... Maybe there is something, right? So my idea is that take is going to clean the buffer and return you a string, right? Fn take, right? So take immutable self, and you get a string. But that essentially just means that we need to take self buffer and simply collect this thing in there, right? And then clean. I think that's what we need, right? So we want to be able to take that thing, then match, like so. And if it's quit, for instance, we may try to break. Right. If it's something else, we're going to simply ignore that. We're going to simply ignore that, but maybe not. Well, yeah, we will need to ignore that. But the next thing is going to be write ln, write ln std out /n/r, maybe /r/n, right? So essentially saying that move to the beginning of the line and then next line, right? So every time you press enter, this is basically what's going to happen. So okay, so this is not a string for whatever reason. Okay, so what's the deal in here? So maybe we have to say string. Come on, we're almost there, by the way. We're almost there. I have to iterate, and maybe since I'm iterating, it's gonna you know, infer it. So I'm hoping that by seeing result in here, it will infer that it has a type string, and since it knows it's a type string, it knows how, to which collect it needs to dispatch. So I'm hoping for that, but that might not be something that the compiler will do. So here is the problem, right? So just by taking it as a reference, it doesn't want it to be a reference. I'm not sure why. Right, so, but it has to be. Expected string, but found, yeah. Can I just say something like as str? Is that something I can do? Okay, so this is something I can do. Okay, let's give it a try. And then, okay, insertion, well, almost there, right. I can do quit at least. Oh, I know. clear line editor self cursor 0. Very important. Very important. Maybe I'm gonna even do something like clear, which takes a mutable self and just, you know, does all of that stuff in here. Self clear. Keiga. Cool. Okay, let's kill everything. So it still does double new line. I'm not really sure. Is that because I don't need this thing in here? I'm gonna give it a try. A few more streams and this will be better than Emacs. I mean, I only started, right? I only started. Huh. So, is that because of this? I'm not quite sure. Oh shit, thank you. Yeah. I should get to a habit of, you know, of using only write without any write-ln. Right, so that's the habit I should get into. Okay, that's cool. I almost re-implemented canonical mod. Or not like a regular mod of bash or whatever. So basically, essentially what I did is that I switched to a raw mode and re-implemented everything that I had in the normal mode. Right, but that way I have a control over like everything, right? So that's cool, I think. So yeah. Now what's important is that I can do some interesting actions. I can do some interesting actions on each and individual key. On each and individual key. For instance, I can try to parse the buffer, right? I can try to parse the buffer and see if it has a valid rule. See what I mean? If it has a valid rule. So maybe we're gonna have something like this. Like every time I can, like I insert a character, right? But then I can take line editor. I'm taking line editor, I'm taking a buffer and I'm starting iterating it. And I have an iterator over characters, which means I can feed it into Alexa. I'm feeding it into Alexa and now I have Alexa that I can feed into parser. How can you have the dot visualization? It's a white space mode. Right. It's a white space mode. So Google up in Emacs white space mode and how to configure it. Right. So that's what it does. It's a built-in thing. You don't have to install anything. All right. So I suppose I can try to do the following thing. Parse. It's not really parse rule, but rather... let me think. Parse... match. Right. So, and in here we're gonna accept Alexa. Right, so Alexa is usually something like this. Alright, Alexa that is accepting the iterator over a character. Alright, try parse. No, we're not using the parse interface of Rust. We have our own parser for all this kind of stuff. No, this is not what we use. At least right now. So, and in here, we're gonna have a result. So usually when I do a fan parse, in the expression, so I'm basically going to be returning a pair, expression head and body, right, or a syntactic error, right? So this is what we want to have in here. And so essentially the head is going to be this, so expression parse Alexa, then we expect token token kind equal, And then we take the body, also parse from Alexa, and once everything's fine, we return head and body. That's what we do. So that means in here, after we did everything, we can try to do parse match, right? And we can do this stuff. Okay, head body. This is not implemented yet. Otherwise, if it's an error, we just ignore that error, we don't do anything. Okay, so once we have head and body, right, once we have head and body, we can find all sub-expressions in them. Right, so this is something that we did at the beginning of the stream. We're finding all of the sub-expressions and we get a vector of all of the sub-expressions. Right, so this is going to be let sub-expr. Here they are. Sub-expr. Then we can essentially highlight all of these sub-expressions and put them into some sort of a buffer, into the pop-up buffer, and display them. And it will happen on each key press, on each individual key press. But this is the problem. This is the problem. You wanted to find the head in the current thing you're shaping. We're not even talking about shaping. What I'm doing right now, I'm trying to come up with a REPL that is capable of doing things. Integrating that into the language, hooking it up into shaping is a completely separate thing. We don't even have a thing that can do stuff. Right, so it's not about shaping, it's not about anything. It's about just, you know, a thing that can do anything. You know what I mean? Right, so what I'm trying to do right now, I'm trying to come up with a pop-up, right? So with a pop-up system. Okay, so we have that. And I'm not quite sure, maybe the line editor is gonna be just making a thing that can do things. Exactly. I need a REPL that can at least show auto-suggestions. Right. I can't auto-suggest for expressions during the shaping if I don't have a thing that can show auto-suggestions. So it's too early to even think about hooking it up into shaping. It's just too early. Right. So let's just like finish the rendering, and then maybe if everything goes right, we can hook it up into shaping. Right now, we're not even thinking about shaping. Okay, so we have this kind of stuff, and yeah, let me see. The problem here is that the line editor and the pop-up have to cooperate. They have to cooperate because we render the line. Right, then we have to print a bunch of things, right? We have to print a bunch of things. Then we have to go up. We have to go up and set the cursor in the right position. See what I mean? So that's kind of the problem in here, right? We have to go up and do this thing. So because of that, line editor, I think, has to be the same stuff, right? It has to be the same thing. So let me see. So pop-up size. Do we have a pop-up size? All right. Let's put it like this: pop-up, and this is going to be vector of strings. Right. So this is a vector of strings. And as we render everything, right? So we rendered the entire stuff. Rendered the entire stuff. I may want to do the following thing, right? I may want to do the following thing where I simply just do /r/n, and then I'm going to iterate over all of the auto suggestions, right? So what was that? A pop-up. Align in self pop-up. Right sync /r/n line. Okay, cool. So we did that, and then we need to now go here, then go up a certain amount of times. Though this one is rather annoying, so I want to kind of fix the amount of things that I want to have in here. So if I enumerate and index is greater than or equal than the pop-up size, I'm going to simply break out of that. And the pop-up size, let's say is going to be 5. Right, so then I'm going to do cursor up, pop-up size. This one is interesting. Pop-up size. We have to find the minimum. Can I do minimum between pop-up size and self pop-up length? Then try into unwrap. Can I do that? So I'm going to do that. So this is one thing. And then it's going to be another thing. Cursor right, which is prompt length plus self cursor. Okay, that's a very complicated logic, but maybe it's going to be worth it. If it's going to be worth it, it's going to be super poggers. Super poggers. Okay, so after that, we have a bunch of sub-expressions, which is nice. I want to iterate through all of these sub-expressions. So I'm going to take line editor and pop-up, right? So I'm cleaning up the pop-up. Then I iterate through the sub-expressions, through each individual one of them, and I want to render them into the pop-up, right? Editor, pop-up, push, format, and here is the thing, highlighted sub-expression, so the stream is slowly going full circle. You see, highlighted sub-expression is something that we developed at the beginning of the stream, then we moved to the terminal stuff, and we're going full circle back to the highlighted sub-expression to put it into the pop-up, right? So that's what we're trying to do in here. So the expression that we're matching is the body, and then put the sub-expression, right? Sub-expression. All right, so I push it there, and that should be it, right? So as soon as you can parse something, it should kick in and show you a bunch of auto suggestions. Unfortunately, it may render in a weird way, right? It may render in a weird way, but that's fine. All of that can be fixed later. So for now, I only care about the, like, you know, this thing at least working, right? So I want this thing to at least work somehow. Okay, what do we have in here? Oh yeah, I keep forgetting, of course. So this is expression, this is a sub-expression. Okay, what else? Enumerate. What don't you like? So I probably have to iterate this thing first. I might as well actually. Can I just take pop-up size amount of things and don't worry about this kind of stuff? I should be able to just take it, right? I think I should be able to do that. Prompt length. Okay, so this one's gonna be try into unwrap. So what else do we have in here? Equals. Almost there. Lexa. Okay. Type mismatch. So what don't you like about this thing? I think I know. I think what I need to do in here is to have a cloned iterator. Right. Okay, almost there. And these are the references, sure. And this thing must be a reference as well. Are we there yet? We seem to be there. Okay, that is very cool. I'm super happy. Okay, it is doing things. So something went wrong, but that's fine. Okay, let me kill everything. Right now I cannot like delete things, but what I can do, where do I have a print? So you see, it did a really weird thing. I put underscore and it managed to, it put one line in here, so that means I did a fucky wacky somewhere, but I'm not sure where. Did I put a print somewhere accidentally? No, I didn't actually. Or right ln right. So this is right std. So if it's a space, I'm not sure actually. I think everything's fine, but yeah. Okay. And now, okay, that's very cool. Yeah, almost there, almost there. This is really strange. So it should have actually moved. So it's a minimum between that thing and that thing, right? But maybe I also have to do +1, right? Because we're going up at 1. So there's coming like a new line from somewhere, but I'm not really sure where it's coming from. You see, like it's a new line. Where is it coming from? Plus a c plus fuck. But it's, yeah, so here are auto suggestions, so to speak, right? So here they are. That's kind of cool. So there's always a new line somewhere there, but I don't really know where it's coming from. But yeah. So I wonder if I can delete things. 78 could be. So what's up with that? Did I put that intentionally, or why did I put that? I'm not quite sure. Yeah, let's give it a try. And because of that, we don't really need +1. Okay, so it's going somewhere. Okay. Oh, thank you, Tien Khan. I hope I'm pronouncing it correctly, for 500 bits. Thank you, thank you, thank you. I won't get them anyway, but I really appreciate them. Oh, fuck. Why? So my brain is not working anymore. My brain is not working, but I need to wrap up the stream already, right? So let's go back, right? And let's just take a look at the current progress, right? So the current progress is probably the most interesting thing. I wish there was a way to delete stuff. Let me see. So we have this kind of thing. So key, delete. Can I even delete? So key, where is delete? There is a delete, which is nice. Line editor, delete. There we go. So let's come up with delete. And when we insert the thing, delete mutable self. Right, and how do we delete things? Rust up, come on. Oh yeah, I'm sorry. So delete backspace. API. Okay, so where is the vector? Come on. I wish I had a better laptop, holy fuck. Okay, so delete. Remove. So remove the thing at a particular index. Okay, so if I want to do backspace, right, I need to do self cursor. And I need to remove the previous one, so it has to be -1, so it has to be self buffer remove. Right, you're removing one thing, and because of that you do self cursor -1. Cool, but you have to be careful. If self cursor greater than 0, only then you can do that. Okay. So I just want to be able to do that to like modify things, otherwise it's kind of difficult to do that. All right, so we have this kind of thing, right? And then I can delete things, which is nice. A multiplied by B, we have that, plus B multiplied by C, we have that. And then I can do plus A. So all of that are outer suggestions. So as you can see, so we can have outer suggestions. At some point I can probably remove that. So this is basically everything that matches these particular patterns. We can try to match different patterns. We can try to match these things, or I don't know. So we can only match those things that are nested multiplications, which is rather interesting. Why does it match this stuff? Right. So why does it match it? But somehow it matches them. Though, yeah, we can try to match something like this. So, and these are the outer suggestions that we sort of have. So maybe this is going to be B, B, C, A, C, D. But I'm not quite sure why does it still keep those things, right? Okay, so these are... So we need to clean some of the lines in here, you see? So some of the... Oh yeah, I see what it keeps them, because we don't clean the lines. That's why. That's why we had some weird previous things. That makes sense. That makes a lot of sense. And also it doesn't clean that stuff. So we need to learn a way how to clean a line. But I don't want to clean the screen, right? So that's the problem. I need to be able to clean the line. So there's a screen. So cleaning the screen. You can clean the current line. Okay, so maybe this is something that I want. Current line. Clear. Can you delete the line? Before cursor, clear the entire screen after cursor. It would be kind of cool to like delete the line somehow, but maybe it doesn't matter. It doesn't matter. What I'm thinking about, yeah. So this one's gonna be clear. And when I'm cleaning the line, does it clear the current line? Does it move the cursor to the beginning of the line? That's a question. Maybe not. We'll see. Where is the render? Where is the render? Okay. Clear. Current line. Current line. So that's what we do with the current line. So we clear the current line, and also in here, we also want to clear the current line. Clear the current line. Though, interestingly, what I'm thinking is that for index in 0 pop-up size, we can do self pop-up get index. We can always try to clean the line. We can always try to clean the line, but only if we have this thing. We're gonna be printing something there, like so. And we're always gonna be doing something like /r/n. That's the way over restitution. Let me see. Doesn't work. So not a value because it has to be let. Seems to be compiling in chat. As you know, if it compiles, it works. No, it doesn't. Okay, so, and in here essentially we'll have to probably just like, I forgot to do that. Can you quit? Thank you very much. Yeah. I'm kind of curious why. Come on, you can do that, I believe you. Yeah. Multiply by that equal A multiplied by B plus C multiplied by D. Okay, so, and if I wanna do something like this. So it matches the whole thing, and then these two things, which is kind of cool. And I also really like how it just keeps that. Okay, so another thing. If it's error, we always clean it up. We can actually clean it up every time, I think. Not really sure. Like, do we really want to do that? Yeah, let's try to clean it every time just to see how it's gonna go. So, okay, so A plus B doesn't match anything. As soon as I do that, it matches that, plus C, C multiplied by D. Though since it's a multiplication, it should be able to also do this kind of stuff, right? So it also matches that internal thing. So here we can just do division. That parsed it really weirdly, but then I can say, okay, match all of the pluses, and there is only one plus in here. Match all of the minuses, and minus is the whole thing, and multiplications, here is 2 multiplications. So this is kind of the outer suggestion that I wanted to do. So this is the framework that we can then use to show the user, like what you can do. So we can also hook up and down to select between the suggestions. Right. So right now we don't really have any highlighting, but in the future I can have a highlighting here, right? So you can do up and down, and you can select, and that will automatically substitute the index at which you want to substitute the rule and whatnot. Right. So, and here is the answer to the question in the chat: why don't you just use a TUI library? And the answer is because I need the level of control that I have in here, so I can do a very specific thing that I just implemented in here. It's a long answer, right? To answer that question, I had to actually type out an implement thing, but that's the answer nonetheless. And the person who asked that question probably already left. So yeah. It's kind of interesting, like people keep asking me like, why don't you use that? Why don't you use that? And the only way I can answer to this question is by literally like implementing the thing I want you to implement in front of their eyes and they usually leave because they all want a very quick answer, right? And the answer is really long, and it basically because I want you to implement this thing, and I can't show you that thing until I implemented it. Right, so, but of course you can probably implement it using some sort of TUI, but I haven't finished that thing yet, right? So you can probably implement the same thing in some TUI thingy, but again, I haven't finished implementing things yet. And quite often I don't even know what exactly I want to implement, right? Because the process of implementing is also a process of exploration. And the more control you have, the deeper you can go in your exploration. Why don't you use TempleOS? Because it has a shitty editor. That's why. Shots fired. Okay. So what else do we have in here? I don't know. We can try to do different things. So if I do swap pair A, B equals swap pair F of X, G of Y, and it actually matched everything. It was also kind of cool if it like showed all of the sub-expressions it matched in here, but I'm not sure how useful that will be. Yeah. Anyway, so that's pretty cool. So does anyone have any question? Are you shrinking the vector suggestion? Oh, okay, so we'll already fix that. All right, that's very cool. So it's not really hooked up into Nock yet, but it will be in the future. And as I already said, I really want in Nock to be able to do the following thing. Right, let me actually show you. So yeah, in Nock, the usual workflow is the following, right? So you start with A plus B, right, square, and you start the shaping, right, and you do the shaping as usual. And I want to be able to say, okay, A squared equal A2 multiplied by A. And then as soon as I press bar, right, I want this auto-suggestion thingy to pop up and show me all of the sub-expressions it matches within the currently shaping thing. And then when I press enter, I wanted to select an index, the index of the sub-expression that I put in here, like 0, right? So that will dramatically improve the workflow. Imagine like typing just something like this, B plus C equal AB plus AC and bar, and it automatically just shows you like here are all of the places where you can put things in. You donated? Good. Thank you so much. So, but to implement that, we need to like finish this REPL auto suggestion thingy, right, and hook it up into the actual Nock REPL, right, and that way we'll be able to do that. Right. So, all right. I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next stream. And hopefully on the next stream we're gonna have pretty cool goddamn REPL, right, without a suggestion and shit. Right, and yeah, we'll see how it goes. We'll see how it goes. Thanks everyone for watching. Thank you so much for the support. Stay safe. Love you all.